So since we have seen about roots right now, so next we will be looking up into the nature of the roots, how the roots will be. So the nature of roots always depends upon the important factor d, which is the discriminant. So let's confine our discussion with the equation ax square plus bx plus c equal to 0. Right. So in this case, d is going to be equal to b square minus 4ac. Right. So now in this case, now depending upon the value of d, the roots of the roots are also determined. So let's say first d is equal to 0, that is b square minus 4ac is becoming 0. Now we know that the roots are minus b plus or minus root over d by 4a. Right. So now what happens if d is becoming 0? It becomes minus b plus or minus 0 by 4a. So we get two roots which are nothing but minus b by 4a and minus b by 4a. What I did was just substituted the value of d as 0 over here. So you get two roots of the same value. So at times when d value becomes 0, then the roots are going to be equal. So roots are equal. Right. So now if d is not equal to 0, then it might be of two types. Either d can be greater than 0 or it can be less than 0. So first let's see the case of d less than 0. So if the value of d becomes less than 0, we get a negative value inside the root. So that is going to be a complex root. So hence we can say that if d is less than 0, we get imaginary roots. Yeah. Right. So now if d is greater than 0, then it can be further classified into two types. It can be either be a perfect square or it is not a perfect square. Now what happens if d is perfect square? Then if d is perfect square, then the root gets cancelled up and we get a rational number. So we get rational roots. Now what happens if d is not a perfect square? Then the root will not be cancelled up and still we get a term with root in it. So this is going to be an irrational root. Irrational roots. So this is a very important topic. So this is pretty useful.